Writing the equation of the line. One suggestion. Create a table of values based upon what we have. We're going to have time. We're going to have x. We're going to have y. Now our time, you can see, goes 1, 2, 3, 4. I can find coordinates at each of those times. So at time equals 1, we're at 3, 2. Time equals 2, we're at 2, 0. Time equals 3, we're at 1, negative 2. Time equals 4, we are at 0, negative 4. We need an equation that gives us our x position. We need an equation that gives us our y position. And we need the range of time, or when does time begin, when does time end? E, it means is an element of, or T begins at the first number and ends at the second number. So it's like the values of T are somewhere in this domain, every number in this domain. It technically means is an element of that set. Well, we can see that's really a line, so we're going to have a linear equation like y equals mx plus b. We're going to have a linear equation like y equals mx plus b. What's our interval for our time?
1 to 4.
1 through 4. So t begins at 1 and ends at 4. T takes on all values, is an element of the set 1 to 4.
How do you know it's like not 4 to 1? Does it have to go?
Time is going to go
Okay.
left to right. So we know it's 1 to 4, not 4 to 1. There's no arrows written on there, but we're going to go left to right. Time is sequential, left to right. So 1 through 4. Looking at the x, well, we're at 3, down to 2, down to 1, down to 0. How is x changing over time? That's subtracting 1. So our slope would really be negative 1. Negative t
Plus 4.
I like that. Thinking, okay, well, there's 1, 2, 3, 4. If we work backwards, if there was a 0 there, well, that would reverse the pattern. It'd be a 4 there. Okay. How about our y?
Negative 2.
So we have a set of parametric equations. We have our horizontal motion. We have our vertical motion. As a different kind of question. I don't have any paper. I thought I had paper. Maybe not. Let's try different.
Why is it plus 4?
For both of them?
Yeah.
So that's like if t is 0 in each case. If t is 0, what would that value be? Well, so 0, 1, 2, 3, 4, this is plus 1, plus 1, plus 1. If, well, going backwards, we'd add 1. When t is 1, we're at 3. If we go backwards 1, we'd be at 4. Same idea for the y. That's doing plus 2, minus 2. That's minus 2, minus 2. Well, when t is 1, we're at 2. We'd go backwards, we'd add 2. John?
In a standard function, that would be like the y-intercept. But like, and that's like, it's not the x-intercept, but the y-intercept.
It's the x-intercept. Well, it's not the intercept on the graph, except if we compare the x to time. We could take this and look at, rather than having x and y, we could have t and x. If t is 1, then x is 3. If t is 2, x was 2. If t is 3, x is 1. If t is 4, x is 0. So we could create a line that doesn't compare x and y, but compares t and x.
So wouldn't you have two graphs, an x graph and a y graph?
If we look separately, we have one equation that's x in terms of t. We have one equation that's y in terms of t. So we would have like two graphs there. But what we're doing is we're taking the x and y and combining them into one. So rather than looking at our horizontal and vertical separate, we're putting them as one line. Okay.
I just forgot I had lines.
Okay. See you later. Here's a different one. Taking an aside, here's a different one.
Thank you.
See you later. Have a nice weekend.
Tiffany, what is it for?
Can we write an equation y equals mx plus b?
Maybe.
Yes.
That gives us that line.
Yes.
Write an equation y equals mx plus b that gives us that line.
Where, can you show me one of those points on the line where it ends?
Y equals 2x minus 4.
And
Thank you.
Oh, this is just. We don't have this one.
no, I
Okay.
just made it up. It's the same one that we just had. Here's a hint. It's the same thing we just had. I just said y equals mx plus b instead of, oops, nope. Instead of our parametrics. Well, John, you actually,
What?
what'd you say?
2x minus 4.
Yeah.
We can find the slope. Notice that we're going over 3, up 6. Y equals 2x minus 4. There's our y-intercept. We have an equation in slope-intercept form. Function form. I will also call this rectangular form.
What's so rectangular about it?
We'll call this rectangular form, rectangular coordinates. What's so rectangular about it? Look at the xy. X and y are perpendicular to each other. So x and y are perpendicular to each other. They make a right angle. So those are rectangular. X is perpendicular to y. Compared to our parametric equations. Compared to our parametric equations, where we have 1 for x, 1 for y. Here's the follow-up. Can we take something in parametric equations and change it to rectangular equations?
Yes.
Of course.
That's good.
Well, we wrote a separate equation, but how can we convert? So can we convert parametric equations to rectangular coordinates?
It would be 2 different graphs.
It's going to be one graph. It better be the same. So convert parametric equations sloppy at that angle. Well, we have x of t is negative t plus 4. We have y of t is negative 2t plus 4. We want to take this and have something like y equals mx plus b. What's one thing that's here in parametric equations that is not in our rectangular coordinates? There is no t, so we need to get rid of the t. I'm gonna forget the t for a moment. I can rewrite this as x equals negative t plus 4. I can rewrite this as y equals negative 2t plus 4. We've got two equations. So I just forgot the function mode, the function format, the x of t. Just x is negative t plus 4, y is negative 2t plus 4. Let's rearrange this. I'm going to turn this into t equals negative x plus 4. I'm going to solve that for t. Now we need to take this and turn this into y equals mx plus b. Since I've got t equals negative x plus 4, how can I get rid of t in the other equation, in the y? Substitute. Substitute. Solve for t. And then we're going to substitute for t. Get y equals negative 2t, which is negative x plus 4, plus 4. Y equals, that's 2x. That'll be minus 8 plus 4. That gets us y equals 2x minus 4.
Can we go the other way?
Can we go the other way? Of course. And actually, I'm just going to point out,
Oh, wait.
that was the equation of the line.
Whoa.
So we can, the point is that we have a way of converting from rectangular to parametric or parametrics to rectangular. We can go one way or the other way. Sometimes parametric is better, sometimes rectangular is better. We need to be able to convert, so can we switch back and forth?
This might be a bad question, but one, would you use one over the other? Like, what's, I don't know.
That bottom right one.
Okay.
That bottom right one, we cannot straightforward write a rectangular equation. That's not a function. But we can write parametric equations that give us a path
Okay.
following along that.
Okay.
So the parametric equation needs to be a function in the traditional sense in order to become an actual rectangular coordinate?
We can write an equation, but it's not going to be a function. Typically, our rectangular coordinates are going to be functions. That one there, that sixth one, this, because we're going up and down and back and forth, we're going to have something sine cosine for x. We're going to have something sine cosine for y. But if we solve for t, we're going to have an inverse sine. And then we're going to have a function where it's cosine of inverse sine, and it's going to be messy working through there.
Can
So,
you put some paper of the conversion
back to that one. Let's go the other direction. I'm gonna.
I'll just take that.
The video is gonna be up on YouTube later.
I'll subscribe.
Good. Oops. Let's convert rectangular to parametric. Y equals. What's our favorite kind of function?
And I still speak.
Just a line? Just a line? What's our favorite kind of curve? Parabolas? Quadratics?
Quadratic.
But-
Infinity curves.
A lemniscate? Lemniscate's easy, not easy for this.
I like lines.
Okay.
That's not a line.
There's a function.
That's not a line.
It's not a line, correct. What does that look like? It's going to be a combination of an exponential and a quadratic. It's probably kind of boring if we look at it. Let's see if I can get it in there. Just to see what that looks like. Second e, 3x plus 1.
Is that the original equation?
That's what I'm giving you. We're going to convert this to parametric equations. Oh, that's not what we want. That's not what we want. That's a slope field. That's calc. All right, there's our graph. Woo! All right, that's kind of boring. It's just there. Kind of a parabola with a little bit extra. parametric equations. We need some x equals, in terms of t. We need some y equals in terms of t. We're gonna do something crazy here. Everybody,
Slow down.
if you feel like we're going too fast and at this time of the year that you need to drop out and maybe just you might want to quit high school after this one. It's just game over. It's so hard. If you can't do this, it's all right. You ready? You ready? Hold on. Hold on. Yes. I build you up the whole year just to knock you down. Right here. This is it. So, 20 years from now, when you're like, why is your life in ruins? It's going to be February 21st, 2020. Leiston. All right, you ready? Here's what I'm going to do.
No.
I'm going to say x equals t.
Okay. Is that it?
I'm going to say x equals t, just t.
Cool.
If x equals t, then y, which is 3 to the 3 e to the 3x, well, x is worth t. 3x, well, it's now x is worth t. X squared, well, x is worth t. All right, that's it. I just made up something that looks scary. Oh, e's a number. E's a number. 2.718, our natural number. So our natural base.
Wait, but what if we started with like y equals 2x minus 4? How are we gonna?
That one. Y equals 2x minus 4. We need an x of t. We need a y of t. Once again, hold on to your hats. You go find a hat, put it on, hold on to it.
X equals 2.
X equals t.
Okay.
Y equals 2t minus 4.
Replace the x with a t.
Why
But
don't we, why
that
can't we?
isn't correct in the sense of we just
It's-
did that problem.
It doesn't look exactly the same,
Yeah.
but now we would have to change, like t would be something else. It's going to be the same curve. We're just going to need to say different start and end. So t is going to change.
Okay.
But that's it. Switch t, x equals to t, replace it. That's it every time.